Yes, we're still talking about LaTeX typesetting, and in this video, our focus is on theorem-style environments in LaTeX. Now, we know that LaTeX is particularly suited for areas involving equations like mathematics, like physics, sometimes chemistry, engineering, and so on and so forth. Of course, that doesn't mean that other people uh, cannot use LaTeX. I mean, I know people who do business using LaTeX to write resumes and CVs because you can get some very nice styles of CVs and resumes using LaTeX. But here, our focus is on mathematics. And you know, in maths, we get to write proofs and things like that. And that is why we're looking at the theorem-style environment in LaTeX. And the learning objectives include to formalize mathematical statements and proofs in LaTeX, to customize theorem environments and numbering schemes, to cross-reference theorems and integrate them with equations, build a mathematical note with multiple theorems and proofs. Okay, first of all, we get introduced to the THM package. So the AMS THM package from the AMS bundle. From the AMS bundle, you have things like AMS Math, AMS Sim, and so on and so forth. And this provide powerful tools for creating. So the AMS THM in particular, it's a package that provides powerful tools for creating theorem-style environments, and it defines things like new theorem and theorem-style commands for consistent formatting of theorems, lemmas, corollaries, and proofs. So the minimal preamble, if you want to use this style, the minimal preamble, of course, there's nothing you can do without documents class, right? So you have documents class, and you specify whether you want to write an article, a report, a book, and all that, or even like a slide that talking about Beamer. So, and then of course you need math packages because before you can be talking about theorems, it means you're working with math probably. So mathematics packages here now, like by now you know that you can mount packages separately. So you can say use package AMS Math, use package AMS Sim, use package AMS THM, or you can also put them together just like the way it is. So you can use one use package to put several packages together. Okay. Then we have cross-referencing support. So if you're interested in working with cross-referencing, you can use HyperRef or CleverRef. So in this case now, for the hyperref, you have some dependencies, so to speak, like color links, which it can be said to be true. Link color can be blue. Site color can also be blue, like that. And then for the clever ref, we have name in link and no abbreviations. Then we have number of equations per section. So if you're interested in making sure that equations are numbered according to sections, such that maybe in section one you have five equations, and then you want your equations to be something like equation 1.1, 1.2, 1.3, 1.4, 1.5, then you need to use backslash number within equation section. So the equations will be numbered according to sections. If not, the equations will be numbered according to the document like that. So you can have in section, maybe in section 5, maybe equation 7, if you don't do this section thing. Okay. Now, talking about the theorem environment proper now, we can then have all this one theorem style. So you do the theorem style and then the new theorem. So you want maybe for a particular one, maybe for theorem, you want it at the section level. So theorems will be named according to sections. Maybe if you have your first theorem is section 3, will be like theorem 3.1. All right. And then lemma, you want lemma to be at the level of theorem 2 that we've defined here. You want corollary to also be at the level of theorem. So that's what all this new theorem thing is about. I'm talking about theorem style. You can also have definition. So this is like a new style now. So you want the theorem style to be definition. That's another way to go. So new theorem is now definition theorem. Definition is at this level. Definition and example are the same level like that for theorem style. So you can have all of this. Then you can have theorem style remark. Maybe you want to make remarks from time to time. Like if you're writing a big book, some of these things may be necessary. Like you want to give examples, you want to have definitions, you want to have theorems, lemmas, and corollaries, and all of that. I also want to have remarks at some point. Okay. So let's look at a basic usage example. Of course, as usual, after everything, uh, we are going to have a mini project where we show all the functionalities of the things I'll be discussing here. So the basic usage example, after you've declared the document class and all the preliminaries, all the AMS Math, AMS Sim, AMS THM, and you've done all the styles and everything, then you can now have the document proper. So begin document section is just a quick demo. So you say begin theorem, end theorem. Okay, so you have a theorem. If A and B it belongs to the real number, no, real number set R with A bigger than B, then there exists a particular epsilon greater than 0 such that A is greater than or equal to B plus epsilon. You know that, let's say that's just a theorem made up. You're going to see this better by the time we get to the mini project. Then here now you also have, so this is the theorem now. You don't want to prove it. To prove it, you have begin proof, end proof. So the proof will now be let var epsilon be equal to a minus b over 2 greater than 0. Then a equals b plus a minus b greater than b plus var epsilon. And then QED here, that means that the proof ends like that. So we can then use, you can then reference that, the theorem itself has been labeled to be THM basic. So we will use THM basic later. All right. So we'll see that in the mini project for sure. Then we have numbering options when we work in the theorem environment. So for instance, we can have number within sections, just like what we said the other time. You have new theorem, theorem, theorem section. You can have global numbering where you just have theorem, theorem. So you just stop here. We don't care about the section. So the theorems will be numbered globally, like you have theorem 1, theorem 2, it just goes on like that. But if you want to do theorem within section, so in section 4, for instance, the first theorem will be theorem 4.1. Now you can also number within subsections, so you have new theorem, theorem, theorem section, subsection rather. Then you can also have a number theorem. So you just have this new theorem star, theorem star. So the theorems are just there without numbering. So if you don't want them numbered, you can have that option too. Then we have custom theorem styles. So here you have new theorem. So this is you customizing stuff now. So new theorem style, fancy plain to sep, top sep. So here you have space above and below the theorem. Then you have IT shape that talks about the body font. So here now you are taking charge of what the theorem environment looks like altogether. You have backslash SC shape, 0.5 em. So here you have head font and punctuation. Then you have all this backslash THM name 1, 2, 3, and so on and so forth. And then you then have theorem style fancy plain, and then new theorem, FTHM theorem. So you can actually define your theme. For instance, and the usage of what we just defined up there is you have begin FTHM. So instead of using the normal begin THM like we had up here, for instance, begin theorem, end theorem. So because you defined FTHM up here now, so you can then have begin FTHM custom style. A custom theorem style can modify heading, font, and spacing. So begin FTHM and end FTHM. Then we can also use cross-referencing, meaning that a theorem you already have, you can refer to it, like you refer to an equation and all of that. So begin theorem and you label because if you need to reference a theorem, of course, you need to label it. So it is that label you're going to refer to later. So begin theorem, label, THM key. Every bounded monotone sequence converges. I think we discussed something like this under real analysis. But here the focus is on, having that theorem now, you want to refer to it later. We now say we refer to theorem. So this number theorem using the clevref package. So the clevref package is why we have backslash cref instead of just ref or equiref that I did that I talked about in a previous video. Now, the next thing is how do you integrate theorems with equations? So if you're going to integrate theorems with equations, if for instance I have begin theorem, you label the theorem to be inequality, right? So you have for x greater than or equal to 0, you have 1 plus x squared greater than or equal to 1 plus 2x. So that ends the theorem. So expand, to do the proof now. So you see the theorem ends here, all right? So, and then the proof, begin proof, and then the proof ends there, down there. Okay, so begin proof. So expanding gives begin equation, you label the equation. So 1 plus x squared equals 1 plus 2x plus x squared, which is greater than or equal to 1 plus 2x because this is 1 plus 2x here. So x squared, no matter how small x is, it is something more than 1 plus. So this whole expression is going to be a bit bigger than 1 plus 2x, right? So since x squared is always greater than 0, then the proof ends. So that's just a simple proof to that thing. So we finally have arrived at the point where we talk about the mini project. So what I'm just going to do is copy this, first of all, to overleaf, and probably to what's that thing now? I always forget. I think this one now. That's Text Studio, Text Studio. But let's go to Overleaf first of all. So now I click on this and then I go to Overleaf. So at Overleaf, I have this typesetting thing, and I've been working with some articles. So I'm going to open a sixth article. So I'm just going to right click on this one and open a new file. Then I call it Article 6. Okay, call it Article 6, and I just create. Then I just paste that in there. Don't forget there's something at the top because I had to do it in the Markdown environment the other time. So I have to remove that to be sure I get the proper thing. So now this automatically compiles. So when it compiles, then we can begin to refer to what we have there. So see the compilation, see what it gives us now. So this is a short note with 3 theorems. So first of all, you see there's this your name here, so you can come and do that. So your name. So I'll just say Emmanuel Jason Dansu as usual. Emmanuel Jason Dansu. So of course that will automatically compile as we know. I set it to auto compile. I think that's way easier. So you see my name shows here now. So coming here now, we have, let's look at all the preliminaries we had to do. So of course we have document class 11 points. Let me even make it 12 points, something bigger. I mean, 11 points is good for articles. 12 points is probably good for thesis or something. So you see the font would have increased a little bit more than what it was before. So this was 11 right here before. So auto compile, it's smaller for sure. So it makes it smaller, but let's go for 12. So don't forget at this level, the biggest you can have is 12, 10, 11, 12. Those are the options. But if you want something bigger, I told you about that the other time, like from tiny up all the way to huge. Okay. So here, so you have document class article use package A4 paper margin 1 inch round. So this 1 inch margin means 1 inch to the left, to the top, to the right, and even to the bottom. It's 1 inch all across for the documents. That's what that inch that paper the margin thing is about. So 1 inch all around like that. Okay. So what else do we have here? Um, okay, we have other things. So we have custom style for last theorem. So for last theorem, we have new theorem style, fancy plain, and then top step. You have all these things we saw up over there the other time. Then this is where you have the title and all of that. So you can see the date is empty. So that's why there's no date here. But if I don't want that, I can just come here and do backslash today or specify or type the particular date I want. So now that I want it to be today, so it's auto compiling and it's going to give us the date right now. So you see October 27, 2025. That's the date for that. So then we come here, begin document, because we have title and all these things. So after begin document, make title has to come after begin document. So if you don't do make title, you won't see that title line. So now I've commented make title. So this title thing is going to disappear because it's not here. You can see the title part has gone. So if you want title to show, so shortly, immediately after begin document, you have to put make title. So now if you go back, you see it is automatically recompiling, and then we have the title back there, right? So we go for the preliminaries. Now we have a definition. So let's see how we define these things up here before. So you can see all this theorem style. For definition, we want it to be at the theorem level, like that has been defined here, like that. Okay. Okay, so I mean, all of this has been the theorem setup. We have all of them, just like we saw when I was explaining in the notes. This is the current custom style for the last theorem now, to just to show the difference. Okay, and then we begin document. So this one you have a definition, and that is what is rendered here. So and because okay, let's see the definition. I think it's at the section level, right? We want the theorem to be at the section level. So it means theorems are numbered according to sections, not globally. So in that case now, in section one, the first theorem is going to be definition, anything, maybe theorem, definition, or anything. So definition 1.1 now says a function f which maps R to R is convex if it satisfies this for all x and y belonging to R and C. So then we also have, so you can see remark one now. Remark one now follows. So anything you do, theorem, corollary, and everything, they take number after themselves under that section. So if I come here, for instance, now, so you can see here, we have definition, begin definition, end definition. Here we have begin remark, end remark. Okay. So if I were to maybe have a corollary and say begin corollary, corollary, and corollary. And I say, maybe I just copy the same thing there. So the numbering will just follow suit. So everything, all the numbers will follow theorem. So now corollary is going to be corollary. So you see definition is 1.1, remark is 1.2, and corollary is 1.3. So it follows that thing. So when we get to another section, automatically the whole thing changes to again start from 2.1 again and goes on. So whether it's theorem, corollary, or anything, the numbers follow themselves. So we have the remark here. If f is differentiable and convex, then we have this expression. So corollary, I just copied and pasted the same thing. Now let's look at the main. Now, by the way, if you want to have if like some I think I really enjoy one ending with in a dot, like one dot, two dots, and everything. So I think I explained that in a previous video. That if you want to have your section number ending with a dot, so you can just come anywhere you like. Maybe use package this use package thing, and just say comma, just add another package called sec dot. So with sec dot, automatically all the section numbers that had no dots, you can see they now automatically have dots. One dot, two dot, three dot, which I feel is more beautiful. That's my preference, by the way. So that's how that goes. So for the main results, and which you find in for the main results, don't forget the first thing was preliminary. So that was a section. That's section one. So for main results, that's section two. So to do a new section, you have to say \section and you type what you need to type. So that's main result here. So here, begin theorem, end theorem. So you see begin theorem here, end theorem. And you can label the theorem. Like this is AM to GM for two numbers. That's arithmetic mean to geometric mean for two numbers. And it is labeled as THM, AM, GM. So to refer to this later, we are going to see where's the reference made to this? Let's see. Okay, maybe not immediately after it. Okay, so you see we have AMGM for two numbers. So for A comma B greater than or equal to 0, we have square root of AB is less than or equal to A plus B divided by 2. So this is the geometric mean and this is the arithmetic mean. Like so with equality, if and only if. So if A is equal to B, then we have equality for the two. So, and then now to do the proof, what do? You say begin proof, end proof. So if either is 0 and claim is clear. So if either is 0, of course, the claim is clear because 0 is just 0. Otherwise, square roots. So see, so to do the proof in short, see, you have the begin proof, end proof. That's this chunk right here. So begin proof, end proof. So all the proof statements come within this two it's that environment kind of thing, begin this and end that. That's the kind of thing you have mostly in LaTeX. So, and we see that for the proof right now. So if either is 0, the claim is clear. Otherwise, square roots minus the square root of a minus square root of b all squared is greater than or equal to 0 gives this expression that a plus b minus 2 roots a plus ab is greater than or equal to 0, which implies that 2 roots ab is less than or equal to a plus b. So you can divide 3 by 2. So divide by 2, that gives the results we are looking for. So that's the simple proof. And you see, because of the proof environment, if anytime you have the proof environment, so it starts with this proof you have here. And then once the proof ends, you have this box here, like that QED kind of box. So that's to show that that's a proof environment, and that's necessitated by the proof statement we have right there. So it's necessitated by the fact that you have written that proof statement. I guess I need to elongate this. Okay. So because we started with begin proof and end proof right here, and that's why we have that. So the proof starts here and it ends right here. So we have a lemma now. So for talking about the lemma, so see that chunk again, begin lemma, end lemma, this portion, and the lemma is labeled Jensen. So let f be convex and x1 up to xn be in the, this whole thing now. So written there. And don't forget, this one is for display or double dollar. So these ones are doing the work of double dollar. And that's what you have right here. So let f be convex and x1 to xn belong to the real number set with non-negative weight lambda I summing to 1, then we have this expression. So again, how do you prove that? So begin proof, end proof, that's another environment entirely for all that. So you now say induct on n. So that's like some mathematical induction. So induct on n. Okay. So for n equals to, this is convexity. If true for n minus 1, we write this expression. With x bar, we have this. So if you apply convexity and the inductive hypothesis, so that simply leads to the proof in brief. So now we have a corollary. So you can see that we have in section 2 now we have theorem 2.1, lemma 2.2, corollary. Anything lemma, corollary, theorem, and all that definition, they take number they follow themselves like that. They are taken together as one based on the definitions we had done before. So when you take a corollary, it doesn't start from 2.1, it just follows like the whole thing with theorem, lemma, and all of that. So for this corollary now, see the environment. We have for non-negative a1 up to an, the square root of a1 to multiply up to an is less than or equal to, this clearer here. So this is like an expansion form of the AMGM thing we saw the other time. And then you have a proof for that. Of course, that comes within this cage, begin proof, end proof. So apply. So here now you're applying the theorem. So you're applying the same theorem 2.2. So you can see because of cross-referencing, it means that if you click on this, it takes you to that theorem 2.2. And how do you reference it from here? You say apply the cross CREF lemma Jensen. So we have the lemma Jensen just up here, right? So this lemma Jensen is right here. So you are referring to that lemma. So if you click on it now, it takes you straight to that lemma. Okay. So that's the work of cross-referencing. So we are using the same theorem, and then we're applying that, which gives the inequality. And then afterwards, we have a theorem, so which is a fancy theorem, by the way. So, and to declare fancy theorem, now this fancy theorem thing was so we have defined it up here. So that's for the last theorem now. So theorem, fancy theorem. So if you want to do fancy theorem, you can use this. So, and to do the actual theorem, you have to declare it as begin fancy theorem, end fancy theorem, like you have here. So fancy theorem, Cauchy-Schwarz, all right. So the theorem, you call it CS. So for X, Y, so within that environment, so it's not just theorem, now it's fancy theorem, which is based on the last one you did. And you see the proof here, begin proof, end proof. You have all of this. So, and what does that look like? Because it's fancy theorem, see so there's a special way the theorem itself is rendered. Where is it now? Yeah, so you see it's now theorem 2.4. So the theorem is written in this capital letter, and it has been specified in that preliminary place. So theorem 2.4 Cauchy-Schwarz. So for x, y belonging to an n-dimensional real number system, you have this expression. So to prove that it's just for t belonging to R, consider q of t to be equal to this whole thing. So its discriminant less than or equal to 0 gives the results. So that's that. These things are just like briefs of the whole thing. So for the final note, now you can just say begin equation and equation, summation of this is greater than 0, and that ends. So the summation of from 1 to n of xi minus tyi all squared is greater than or equal to 0, basically. So these just possible ways to get around all of these things. Now, okay, well, of course, I can just copy this same thing. I can copy this same thing to Text Studio. I can copy it to Text Studio. And when I get to Text Studio, I can either open a new document or overwrite a document that was there before. But I think it's cooler to just open a new document. So I just open this and then I paste this, all right, and then I can run it, and then it generates the PDF. For overleaf, you can just, so this is the PDF we generated straight up, right? So this is a PDF here. So we can save this we can save this somewhere and then use it later. Or, for the sake of, for overleaf, to get the PDF out, this is where you come to, you click on this and it automatically just downloads. So, and then you can find this in downloads here. So this is right here. So you can just find it here. And then this is the document itself. So with that, we gradually are drawing to a close as far as that is concerned. Now, if you want to have access to this specific thing I've just done, that's why I did it in this markdown format. So if you check, how am I doing this? in case you need it, right? Because you can actually do it your own way. But if you need it, I mean, you can just send me a message wherever, and I can send it to you. So all you just need to do is open it in the markdown environment like this, maybe in Google Colab, and then by the time you double click, so if you want to get this particular thing, just double click on this and copy and paste it. And don't forget to remove the first two lines that made it into markdown like this. So this line now, or you can remove this whole thing, or you can remove only this one. I mean, it's better to remove the whole thing so that it starts with documents class. And then you copy and paste it, and you can then tweak it as you wish. Okay. So, with that in place, let's remember in summary. So, use AMSTHM to define theorem-style environments. Choose numbering scheme and style. Maybe it can be plain, definition, remark. Then label and cross-reference with cref. You can integrate theorems and equations seamlessly, like we saw in our mini project. You can customize appearance using new theorem style, just like we saw for that new theorem style, right? Like that theorem that came out in capital letters. So you can specify those things. The mini project demonstrate professional mathematical notes composition. With this, I come to the end of this interesting video about theorem style environments in LaTeX. So if you're working with theorems, definitions, remarks, examples, lemmas, and everything, you can actually get this working following the things I've talked about. Let me know how helpful this is for you. And if there's something else you'd like me to deal with, let me know also. If you have subscribed already, I thank you so much. If you haven't subscribed, of course, you want to do that right away. Go ahead and subscribe and hit the notification bell so you can always get alerted each time a new video is released. Having done that, you want to click on join to become a member of this channel, and that comes to some special privileges, right? Ultimately, don't forget to comment, like, and share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing LaTeX right. Bye.